Next, we'll discuss graphs of quadratic functions. We already mentioned if the leading coefficient is greater than 0, the parabola opens up. If it's less than 0, the parabola opens down. We have the vertices, one to a parabola, called HK. And it would be great if we had a formula to find that vertex, and son of a gun we do. There it is, negative b over 2a. I wonder how we can remember that. We'll come up with something. And as for k, well, h is an x value and k is a y value, so it stands to reason that k is h pushed through the function. So it's f of h, in other words, it's f of negative b over 2a. So that makes the coordinates of the vertex what you see here, and I should have another parenthesis here, shouldn't I? And the axis is x equal to h as it was before, or now that we have a way to find h, we can say x is equal to that expression, negative b over 2a. Okay, that looks like an axis. I wonder what comes next. What does come next? I sure would like to find another point on the graph without having to do a whole table and everything. Well, the easiest point to find is the one that we get if we let x be equal to 0, in other words, the y-intercept of the graph. And that's easy because if x is 0, then the a and b amount to nothing, and all that's left is this constant term c. So we know that 0, comma, the constant term, is always going to be a point on the graph of the function. So maybe it's up there. Now, the cool thing about this, apart from it being so easy to find, is that it gives us, right in our hand, another point that's on the function. How come? Think about that axis of symmetry, because that's how come. If I go from the y-intercept to the axis, and then the same distance again in a line perpendicular to the axis, I find another point, because this point has another symmetrical point, same measure away from the axis, on the other side of the axis. So, that's very good. Now we have 3 points. We already know whether it's going to open up or down. And since this is the vertex, in this case, it can only go up through those 2 points. So, to get a decent sketch of this graph, we are going to try to make a nice curve that goes through all points. Don't make it pointy down here, make it rounded. Now, some of these days it's going to be a good thing to be able to find those x-intercepts. I'm going to let you think about how that's done. Do observe that they are also at the same distance as each other from the vertical axis, one left, one right. Okay. So here's a sample problem from the book. Find the vertex and the y-intercept and then graph. Okay, so we have to remember from the previous slide our formula for finding the vertex, the negative b over 2a, and then we have to not mess up any of the signs, so I have negative my b value, which in this case happens to be negative. I do not forget to multiply in the denominator by 2, and in this case, ultimately, I get h is equal to 2. Poke that 2 through the function, and I get negative 11. Okay, so there's my vertex. And I can also immediately find my y-intercept by putting 0 in the function, which gives me a 1. So now I have 2 points on the graph, which opens up. Going to look like this, and I get another point because of the symmetry. There we go. And now connect these with a nice curve. I also know what that point is because it was 2 to the left here, so it's 2 to the right there. If the vertex happened to be on the other side of the vertical axis of the coordinate plane, then I'd still have 2 to the left and 2 to the right, but I would start with 1 on the right. There's my curve. Domain is all the reals, and the range from -11 up, and since -11 is in the range, I have the square bracket there. More fun than a table of values. Well, what isn't? And that is the last slide for this part of our lesson on graphing.